Hey guys, welcome to GeeklyEDU. Roses are red, the sky is blue, the earth is brown and the leaves are green. What do you think? Are they actually those colors or does our brain cook them up? For one, it's very difficult for most of us to imagine our world without colors. But are colors real or do we imagine them? To understand colors, let's try to understand how our eyes are really built. So if you go and talk about our eyes, there are three primary layers of the eye. The outermost sclera kind of protects the eye. The next one, inner to sclera, is called choroid. It sort of absorbs the reflected rays so that we do not have multiple images. And the inner one, the real game changer of our eye, is the retina. Retina has got again two layers, a pigmented layer and a nervous layer. Now, the real deal goes on in this nervous layer. Now, this nervous layer has again got three layers of neuronal cells, or simply three layers of neurons. What are those? Well, I would like to describe them inside out. That means, let's first talk about the neurons towards the inside of the eye. And what is that? Those cells are called photoreceptor cells, which you might have heard rods and cones. Why are they called rods and cones? Because they look like rods. The rod photoreceptor cells look like a rod, like stumps of the cricket, and the cones, they look a little bit like corn. The next one is a layer of bipolar cells which connect the photoreceptor neurons to the outermost layer, which consists of the ganglion cells. From the ganglion cells, the nerve fibers take the information to the brain for processing. Now, the real deal happens in the photoreceptor cell layer. Now, as I said, there are about two types, rods and cones. We have about 120 million rods in our eyes and about 6 million cones. You might think rods are more important, but actually rods give you vision even in a low light, but they can only differentiate between light and dark and the spectrum in between. Whereas the cones are the ones which are really to be blamed for colors. So there are three types of cones, and yes, you can expect them to detect three different wavelengths. Now, when I say three different wavelengths, I mean three different range of wavelength. The highermost wavelength, that is of the red, which has got lower energy, and then we have the middle one, that is green, and the accompanied range of wavelengths, and the lowest one, that is the blue, which has got the highest energy. So these different cones R, G, B are activated with the help of different wavelengths of light. And no, they are not colored. They simply have different wavelengths, and your different cones are able to respond to those specific wavelengths. When wavelength of, let's say, the red light hits those photoreceptor cells cones of the red one, they are excited and the message is sent to the brain. This theory was put forward and developed by two scientists, Young and Helmholtz. Hence, it's also known as Young-Helmholtz theory of tricolors or trichromatic theory. So they said that whatever color we see is actually based on the stimulation of these photoreceptor cones, and the in-between colors are because of the different amount of stimulation that they receive from the wavelength that is coming to us. If they all are equally stimulated, then obviously we see the white light or the white color. But I want you to do an exercise. Pick up something green, stare for it for about a minute in the brightest atmosphere around you, and then immediately look at a white sheet of paper, you might end up seeing something red. Why is this? So this phenomena is called having an after image. And if the RGB are the three main types of cones that we use, then this after image cannot be explained using this theory. But can we say that that theory is wrong? No, that theory is correct, but it is not the whole explanation. So another scientist called Ewald Hering explained that we actually see as dual things. So green and red. Look at the white sheet of paper, you start seeing red because the green has fatigued, right? This is called the theory of opposites given by Ewald Hering. But this again is a little bit incomplete. Why so? Because they did not propose how this actually happens, and these happens because of special connections in between these different types of cones, which have been found. So the first theory is not wrong. Now let's talk about something entirely different. Right now I'm wearing a white shirt. Now there are two situations when you can think that this is somewhat green. One situation, I actually wear a green t-shirt. But if you shine a green light on the t-shirt, then also it appears a little bit green, but somehow you can recognize that yes, it's the light that's green, not the t-shirt. Why? Because we always see colors when we compare. So that is known as the Retinex theory. And that explains why several times, even though we know the real color, we might see different, but we know the real color, even though the real color and the light that's shining it are different. I hope this session helps you understand that color which we see is actually something that our brain sees. It's not in real, right? So I hope this session helped, and if you want more of these videos on weird things that science can really explain, let us know down in the comments. Stay geekly.